Good morning, students. Continuation of the problems, textbook problems, 7.1 next problem. This is actually conceptual. It is a 1 mark question also for competitive exams, also important. Solid sphere, whether whatever is the object is a circular object. In this case given as a solid sphere. Rolls down on two different inclined planes of same height but different angles of inclination, different angles. Height is same, slopes different. Slope is standardized related to slope, more theta, more slope we call it. As very near to this vertical height you have taken, means more angle you find, more slope. This less slope but more length will be there, reverse. More angle, less length of the path and the inclination. But height is same. The condition is that will it reach the bottom with the same speed in each case? Will it reach bottom same speed or different speed? We have to check up that. In which case it takes more time to roll down. We have to check up on both the cases. It is solid sphere. Values given means we require this formula, otherwise it's actually not required. The values, numbers not required. In this case it is a theoretical concept question. Solid sphere, I is equals to 2 by 5 mr square, which is equal to mk square. Any I equal to mk square you can take. K is a radius of gyration and k square by r square mass cancels. K square by r square is 2 by 5. So this is required if values are given. Next on the inclined plane, what is the formula for the acceleration is A equal to g sin theta by 1 plus k square by r square. We derived that in the previous class, you have to remember this. Next final velocity at the bottom, v equal to v square equal to u square plus 2as. Equation of motion for kinematic equation of motion for rolling motion already we discussed before. Just like the straight line motion we have to take v equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as. S is the length of inclination L, you can take s1 s2 or l1 l2. In this case, if the object starts from rest, u is 0. V is the final velocity at the bottom. And length of the inclination is L. L is equals to ut plus half. We find out the time taken to travel the distance L. And v square equal to u square plus 2al or 2as. The distance and velocity relation. Starting from rest means u is 0. Wherever s is there, you can replace with L. Another thing is, this is for rolling down. They may ask you the question reverse. Rolling up. One object is rolling and coming to the inclined plane. What height it travels? How much time it takes to travel the maximum height? How much time to come down? All those formulas, same formulas you have to take. Going up means final velocity v0. Coming down means initial velocity u0 you have to take with the same equations. While going up, acceleration formula g sin theta by 1 plus k square by r square. And this is a retardation. When it is going up, retardation means minus a you have to take. Coming down, you have to take it as a positive a. Next is final velocity v square equal to u square plus 2as. So u is 0 here. So this formula we use there. V square equal to u square plus 2as. So v equal to root of 2al, it is 2al. Wherever as is no, a equal to g sin theta by 1 plus k square by r square. K and r constant because only one object you are taking, that is a sphere. K square r square is 2 by 5. And a equal to g sin theta by 1 plus k square by r square. L. What is sin theta? If you take this triangle, this slope, this is a theta, this is h, this is L. So sin theta is nothing but equal to h by L. And the L becomes equal to h by sin theta. Or L is equals to, if you have taken here, h is equals to, if you require no, L sin theta it becomes. But in this case, we are replacing for L. L is nothing but equal to h by sin theta. Sin theta cancels. So remaining expression v equal to root of 2h by 1 plus k square by r square. For the given sphere, k square by r square is constant, that is 2 by 5. And h is also constant because in the question itself says that same height. H is constant. G is anyway constant. Then in that case velocity is constant. So that means velocity is independent of the angles. So we do not depend on the angle. That point is important. So first option, will it reach the bottom with the same speed in each case means answer is yes. Velocity independent of the angles. Velocity do not depend on theta. Even though it is traveling more length here, it is traveling more distance, you are having less distance, but final expression do not depend on that L relation and do not depend, depends only on h, do not depend on theta. So h is constant means, in that case velocity is also constant. So v1 is equals to v2. Next is time taken to reach the bottom. The rolling object, time taken to reach the bottom. We have the equation s equal to ut plus half at square. S means L we have taken here. U is 0. So L equal to half at square. T is equals to 2L by A. L is equals to h by sin theta and A equal to g sin theta by 1 plus k square by r square. Sin theta into sin theta is sin square theta comes out. Remaining is 2h by g only remains into 1 plus k square by r square, go to the numerator of this, inside the root only. These are all constant terms. So what you have to take is t is inversely related to sin theta. If theta is more means sin theta is also more, and theta is less means sin theta is less. When theta increases, sin theta increases means time less. So in this case, theta is more here. When theta is more, theta 1 is more. Theta 1 is more than theta 2. More theta means what? Time is less. So in this case, time taken for this slope is t1. Time taken this slope is t2. Here it takes less time, this takes more time. So t1 is less than t2. More slope, less time it takes. But v1, here it is v1 and here it is v2. But v1 is equals to v2. So what you get the relation is theta1 greater than theta2 in these expressions in the diagram example. T1 is less than t2. More slope, more angle means less time of descent it takes. Next one is 7.19. A hoop of radius 2 meters weighing 100 kg. Weighing 100 kg. A loop of radius 2 meters weighing 100 kg rolling along the horizontal floor is rolling on the horizontal floor. So that center of mass has a speed 20 centimeter per second. Its center of mass has speed 20 centimeter per second. Careful with the units. How much work is required to stop it? Find work done or work is required to stop it. Already it is having, it is a hoop, loop, ring, hollow cylinder. Rolling conditions are same. So mass is located at the end point, stem or rim we can take. It is called as a loop. Velocity is, this is a VCM. Velocity is VCM, center of mass velocity V only I am taking. This center of mass velocity means translatory velocity is given. It is also having the rolling motion. So total kinetic energy is rotational kinetic energy plus translator kinetic energy. If you want to stop it, work done is equals to change in kinetic energy. It is a hoop or ring, radius is 2 meters and mass is weighing. Sometimes if they give newtons means that is supposed to be mg weight, but here only kgs given means mass. Mass equal to 100 kg. Velocity v equal to 20 centimeter per second, which is 0.2 meters per second. Find the work done to stop it. You have to find out the kinetic energy, and it is a ring. For ring, moment of inertia is equals to I equal to m k square is equals to mr square. Mm cancels, therefore k square by r square is equals to 1. Next, work done is equals to rotational total kinetic energy. What is kinetic energy? Total kinetic energy. Rotational kinetic energy plus translated kinetic energy. Total kinetic energy is equals to kinetic energy rotational plus kinetic energy translational, which is equals to half mv square plus half rotational is anything can be first, no problem actually. Half mv square plus half I omega square. So total kinetic energy half mv square into 1 plus k square by r square is the formula we have. One plus k square by r square is total energy that we need to work out. Next is work done to stop is equals to change in kinetic energy delta K. You are stopping, it means final kinetic energy is 0. That means kinetic energy final minus kinetic energy initial. Kinetic energy final is 0, coming to rest. So you have to take only the initial kinetic energy. Final is less than initial, or you get negative. Negative means work done is a decrease in kinetic energy. Don't bother much of this negative sign here. Otherwise, you take the initial minus final kinetic energy. Generally, final difference means final minus initial will take, but here we are taking is initial minus kinetic energy final. Kinetic energy final is 0 because we are making V equal to 0. Coming to rest. So work done is nothing but equal to half this formula, half mv square into 1 plus k square by r square. If the velocity change is given means half mv square, first case half mu square initial kinetic energy, half mv square is final kinetic energy you are taking. So we take this initial velocity u will take. I am taking this as u. Final velocity v is 0 we are taking. Symbol is not important because no need to take initial final separately, just take the kinetic energy means half mv square only. We can also take a half into mass is 100 into velocity square 0.2 into 0.2 into 1 plus k square by r square is 1. That is for the ring only. So this becomes equal to 2 cancels. Result is 100 into 0.2 into 0.04 into 2 by 2 cancels. These 2 is cancels now. 4 joules of work is to be done. Next to 7.21. A solid cylinder rolls up inclined plane of angle of inclination 30 degrees. Up and inclined plane of angle of inclination 30 degrees. At the bottom of the inclined plane, the center of mass of cylinder has a speed 5 meter per second. At the bottom of inclined plane, the center of mass has speed of 5 meters per second. How far will the cylinder go up the plane? A bit. Does it go on the inclined plane? B bit. How long will it take to return to the bottom? How much time it take to time of descent? Time of ascent plus time of descent, going up and coming down, both the time is given. Inclined plane, theta h l. Something already rolling with the velocity v and going up. Initial velocity u will take. And how much time at the bottom of this plane? Velocity is u. Then it is going to some height will take. The length I am taking is up to this only, where the final velocity v is 0, it's stopping. Going upwards means acceleration taken as a retardation conditions. Solid cylinder it is. Solid cylinder, I equal to mr square by 2, which is equals to mk square. Mm cancels. The result is k square by r square equal to 1 by 2. Acceleration A equal to g sin theta by 1 plus k square by r square. And distance they asked one is how far distance? S equal to ut plus half at square we can take, or t is not asked here for the case. T also, of course, t also required, and we can take the final velocity is v square equal to u square plus 2as also we can take, because L we are calculating here. V is 0, u is given for us, u is 5 meter per second, v is 0 at maximum height. After reaching maximum height or maximum distance travelled, maximum height or distance conditions. Theta is the angle of inclination. Of course, I am not giving the relationship. Next is L, distance travelled. Distance travelled on inclined surface. So what is the formula we have for this is S equal to ut plus half at square, means L equal to, sorry, not time also we can find out. How far it goes means distance a bit. S v square equal to u square plus 2as 2al. V is 0 here and a is equals to retardation. Is a minus, you have to take retardation, upward motion. For upward motion, downwards means plus you have to take. So v is 0, this is a u square, this is a minus, it becomes. The result is distance travelled L is equals to u square by 2a. If you remember the formulas for the vertical motions, that formulas we can use here. Maximum height reached is equals to u square by 2g. G, wherever g is replace with a. A is g sin theta by 1 plus k square by r square. L equal to u square by 2a, which is equals to u square by 2 into a is g sin theta. After putting minus only, taken to the right side, it becomes equal to plus here. No need to put once again minus, by 1 plus k square by r square. K square by r square is 1 by 2. The result is L is equals to u square means, okay, writing the steps as it is, by 2g into sine 30 is half into 1 plus k square by r square. U is 5 into 5 by 2 into 9.8 into sine 30 is 1 by 2 into 1 plus 1 by 2 is 3 by 2. I am writing this value out directly, 3 by 2. 1 plus k square by r square equal to 3 by 2. This 2 cancels. You will get this as a 10 and 25 into 3 by 2. L is equals to 25 into 3 into 9.8 into 3 by 2. The result is so many meters. That I will check up. Next to B bit, time taken to go up. You can take final velocity v equal to 0. You have to find out the t, time of ascent. You can take the relationship v equal to u plus at. If you take in the upward direction is upwards. T equal to t I can take, that is time of ascent. Td is also equal to time of ascent, that is time of descent. Neglecting air resistance, time of ascent equal to time of descent. So one time you have taken means total time of flight is time of ascent plus time of descent, some both you have to take it. Question is how much time taken to return to the ground, means going up and coming back it is take. Time of ascent if you calculate, automatically double to that you will get the time of flight, flight like time of coming return. Now you can take it, time of return t equal to time of ascent plus time of descent. This is total time, that is 2 times time of ascent. Now let us take what is the time of ascent. V is 0, coming final velocity is 0 and a substitute the value here. So time of ascent is equals to, this becomes equal to, this is minus, you will get minus g sin theta into t. So v is 0, take it to the other side, becomes plus. Time of ascent is u by a, which is equals to u by a is g sin theta by 1 plus k square by r square, which is equals to u by g sin 30 into 1 plus k square by r square, which is 3 by 2. Time of ascent is equals to 5 by g 9.8 into sin 30 is half into 3 by 2, 2 cancels, result is 15 by 9.8, which is equals to 1.53 I think. Therefore time of return, total time equal to 2 times, which is equals to 3.06 seconds. That I will check up the calculations. You also verify the calculations of the last step. .826 meters, and this time is 1.5 by 9.8, 1.5306 seconds. Time of return is double to that you have to take. to this we can stop, but I will give you the hints for some other problems that I skipped. You have to work out problems 7.1, 7.2. I already worked out, but still I am giving the number that you need to go through. 7.3, 7.4. I am going to give the hint for this. 7.5. 7.7 is given on the solved exam problem that you have to go through. 7.8, this is important for the competitive exams. 7.8. 7.9 not required. 7.10. 7.11 important for the competitive exams also, just have to go through that. 7.12, 7.13. I worked already these problems. 7.14, 7.15, 7.16, 7.17, 18, 19, 21. 7.20 we can leave the problem. That is related to the oxygen molecule, kinetic energy, rotational total energy, sum of the two energies that you can check up. That's not important ones. Next, these hints I will give you for the problem. 7.8 and 7.4 and 7.5. You are given a plate or rod hanging between the two walls at the end points. .9. This angle is 53.1. This is 2 meters. L equal to weight is some place here, that is W at a distance of D. This D we have to find out. A non-uniform bar of weight W is suspended. Non-uniform means weight is not equal everywhere. So if uniform bar means center will be the weight you will be acting, but if non-uniform means more weight is this side, so center of gravity will be towards the larger weight side. Rest by two strings of the negligible weight. The angles made by the strings are as vertical are given 36 minus. The bar is 2 meters long. Calculate the distance of the center of gravity to the bar at its left end. So to take the calculation purpose, we take the help of the tensions. Tensions. This is T1. This is T2. T1 and T2 resolve into components. This is theta, you can take vertical with vertical, or with horizontal you can take the angles, components. In this question, a rod, non-uniform rod is suspended with the help of the two threads fixed to the horizontal wall, vertical walls on the sides. The ropes here or strings have the tensions T1 and T2. Angles given in the diagram 36.9, 53.1 degrees. Generally, don't give in this type of problems of the tough angles, because here these the angles you require logarithm tables. But without that only you will be given the problem. Generally 35, 30 degrees, 6 degrees like that problems will be given. Procedure you have to understand to solve the problems, important for competitive exams. So this tension is down to components, vertical component and horizontal component. This angle are equal. Vertical component, known angle side is cos angle, you have to take T1 cos 36.9, T1 sin 36.9. Similarly, T2 also resolved to components, T2 cos 53.1, T2 sin 53.1. So in this case, weight is acting from center of gravity. Non-uniform rod, center of gravity toward large weight side. So let us think that center of gravity is this side more. This side thin, this side is more thickness. So center of gravity is here. Instead of that problem, they may give you light rod and some weight is hanging here. That weight position you have to find out. Weight, sometimes they will ask you the weight, sometimes they will ask you the distance d. If they give the d, they may ask you the weight w. Now next, at equilibrium, upward force equal to downward force, left side force equal to right side force. Means along the x-axis, y-axis, net force is 0. Then this is for translator equilibrium. Upward force is T1 cos 36.9 is supposed to be equal to total upward force. This is a plus. This total upward force is supposed to be equal to downward force is W. Okay, and horizontally what you have is horizontally T1. This is not required, but in case W asked means you require. Otherwise, this part is not required. This is equation 1. Next is horizontally there is no displacement. Therefore, left side force equal to right side force. T1 sin 36.9 equal to T2 sin 53.1. So this part 53.1. In that case, T1 by T2 ratio will get the relationship equal to sin 53.1 by sin 36.9. The relation. This you have to calculate how much it is. The result will be 4 by 3 you will get. This value will be 4 by 3 equal to dash. This is equation 2. Next is for rotational equilibrium, clockwise moments equal to anti-clockwise moments. Any point you can take for the axis of rotation. You can take this point also, but here W is not given, so better take that point only as axis of rotation, because if you take that axis of rotation, the weight into the distance, moment of force, because that weight will be 0, and in the equations we can neglect that. So about this point only axis of rotation if you have taken, then the rod is trying to rotate like this because of this T1 cos 90, and horizontal forces do not rotate. And this vertical force again T2 cos component will try to rotate in this direction. So this is a clockwise rotation, this is an anti-clockwise rotation. So moment is equal to moment of force. Moment means moment of force is a torque, force into distance. So T1 component, cos component into the distance, perpendicular distance is d. D into T1 cos theta is clockwise moment of force. And the anti-clockwise moment of force is T2 cos component into this distance. Total length is L, means L minus d. L is given as a 2 meters for us. So the clockwise, sum of the clockwise moments equal to sum of the anti-clockwise moments, which is nothing but equal to T1 cos 36.9 into distance is d equal to T2 cos 53.1 into the distance is L minus d. This distance is nothing but equal to L minus d. L minus d. And then T1 by T2 you take the relation. T1 by T2 is T2 left to the left side, the cos the component go to the right side into L minus d by d comes. So T1 by T2 from this 1 and 2 and this equation 3, 1 is not required in this problem. T1 by T2 value, that is 4 by 3, you will get substitute here, and cos comp values I gave the values here. You can take, you will use these values for substitution into L minus d by d. From that you will get the sine here cos. You can use the tan if you want. You can take that as you left if it gets, you check up what you get. Next is L minus d by t. Left side you got the expression, so L minus d by d equate it. L already you know it. L is nothing but equal to, L is 2 meters. Substitute the values here and d you have to calculate. That value you will get is 0.72 meters. The T1 by T2 is 4 by 3 you will get. This first equation is not required in this case. If they ask you weight also, then use substitution of that cos component T1 T2 ratio. Sorry, you have to calculate this W purpose required. You ratio this, you can take T1 and T2 and substitute the values here and solve the equations. After substituting d, and you will get the expression for W also. Upward force equal to downward force.